Assalamualaikum, I am Sulaiman Josli from AS120-210. In this video, my friends and I will be presenting on the topic of application of differentiation, apply maximum and minimum. Introduction for maximum, the application of a differentiation play a crucial role in maximizing outcomes such as a profit and efficiency in a various field. Professionals use the differentiation to optimize strategies and processes, ensuring optimal performance and resource utilization. Introduction for minimum, in the application of a differentiation, professionals across industry utilize in the principle to minimize cost and optimize efficiency. By leveraging differentiation technique, they can pinpoint optimal configuration that balance structure integrity with cost effectiveness.
Then, this is our problem statement. A rectangular mirror 5 meters square will be made. Mirror price of the long side is 5 ringgit per meter, while the broad side are 1 ringgit per meter. Let X represent the long side and let Y represent the broad sides of the mirror. A. Show that the cost C of the material is given by C equal to 50 over Y plus 2Y. B. Find the values of X and Y that will minimize the cost of the material. C. Hence, find the minimum cost of the rectangular mirror. So, this is our study case. The question is, a rectangular of mirror is given by 5 meters square will be made. The mirror price of the long side are 5 ringgit per meter, while the broad side are 1 ringgit per meter. Let X represent the long side and let Y represent the broad sides of the mirror. Question 1 is show that the cost is C equal to 50 over Y plus 2Y. Okay, firstly, we know that the long side is X is 5 ringgit per meter and for Y is 1 ringgit per meter. Okay, then we must make our on C is cost. So the cost must multiply with the side. We know that X, we have two sides, X, and also Y and Y. Then we just multiply. Then we got the C. This is our C is equal to 10X plus 2Y. And after that, we know XY is equal to a rectangular of the mirror. And a rectangular of the mirror is given by 5 meters square. Then we just move Y to the other side and we got the X equal to 5 over Y. Then we substitute X that we get in C, in our C. So C is 10X plus 2Y. So we substitute X. So X equal to 5 over Y, then plus 2Y. So multiply. 10 multiply with 5 over Y is equal to 50 over Y plus 2Y. So this is showing that the cost is C equal to 50 over Y plus 2Y.
Okay, next, find the value of X and Y that will minimize the cost of the material. So first, how we want to find it? We know that C is equal to 15 over Y plus 2Y. Next, we differentiate the C and we will got negative 15Y power of negative 2 plus 2. And simplify it, we will got negative 15 over Y square plus 2. Next, we the product of differentiate, we will equal to the 0 and 2 will move to the other side and will become 2 equal to 15 over Y square. Next, we move y square to the 2 side and we will get 2y square equal to 15. Okay, then 2 move to the 15 side and we will got y square equal to 15 over 2. And we will got 25. Then we want to find only y. So we have to move the power of 2 to the other side. We will square root the 25 and we will get 5. Next, to find maximum or minimum point, we will use second derivative, which means first derivative, we differentiate again. Okay. Negative 2 times negative 15 times y, power of negative 2 minus 1 is equal to 100 y power of negative 3. So we simplify, we will got 100 over y power of 3. Then, to find minimum or maximum point, we will sub y equal to 5 into the second derivative, which means 100 over 5 power of 3. Then we will got 4 over 5. Okay, this shown that this is a minimum point because 4 over 5 is greater than 0. Okay, last. Okay, we have got the value of y, which means y is equal to 5. Then we want to find x. So we will use the first equation, which means x equal to 5 over y. Next, we sub 5 into the y. So 5 over 5, we will got 1. Then,
so we know that the minimum cost for the rectangular mirror is C equal to 50 over y plus 2y. So we know that when y is equal to 5, we only need to substitute the y into this equation, which is C equal to 50 over 5 plus 2 times 5. And then we got the final answer is 20 ringgit for the cost for the rectangular mirror. Hence, minimum cost for the mirror is Rm 20 ringgit.
for this slide is about the conclusion for our base question. So, in summary, the use of maximum and minimum value in the calculus offer effective strategies for the solving optimization problem and making well-informed decisions by utilizing differentiation and critical point analysis. We can pinpoint potential extreme point and determine their characteristic with the first and second derivative test. These techniques allow you to identify the highest and lowest point of a function in a specific content. So, this is for our conclusion. So, thank you for watching. Bye.